All right, I want to find the domain of this function. And for a radical, what you have to worry about for domain are when what's inside the radical becomes a negative. You don't care about this 7 or 5. It has nothing to do with the domain. They're just there to kind of throw you off. What you care about is making this positive or 0. So what I do is I make this positive or 0 and solve it. And the way we make it that is as follows. We write 12 minus 3x is positive or 0. That's what that means. 12 minus 3x is greater than or equal to 0 means that is positive or 0. So now we solve it. To solve this, we minus the 12 over. All right, cross that out. We got negative 3x is greater than or equal to negative 12. We divide both sides by negative 3. And that you get crosses out. That gives you x. This gives you 4 over here. And doesn't the inequality do a little flipperooski? So it goes the opposite direction, which is kind of interesting. What happens is we talk mostly about square roots going like this. This one is going the opposite direction, starting there, has a backwards flipping effect. And why is that the case? Because there's a negative on the x. When there's a negative on the x, it does a backwards flipping effect horizontally. It's weird. We haven't been doing those in the class, but it can happen. So next, we want to find the average rate of change from 1 to 4 of this function g. All right, so to get the average rate of change, we want the slope from 1 to 4. And to find a slope, we have to have coordinates. If you remember, to get slope, there's a formula. M equals y2 minus y1 over x2 minus x1. You have to find two coordinates in order to find slope because we don't have the picture. Normally we've found average rate of change in the past with pictures. Now we don't have the picture. So can you do it with an equation? Can you find two exact coordinates? From those two coordinates, can you use this formula and produce the slope or average rate of change? So we have to find two coordinates. Isn't one coordinate going to be at 1 and one coordinate going to be at 4? The edges. So can we put 1 into this and can we put 4 into this? Watch what happens. So we're going to do g of 1. That's going to be 7 plus 5, the square root of 12 minus 3 times 1. What does that give us? Let's see. 7 plus 5 times the square root of 12 minus 3, isn't that 9? So won't that be 7 plus 5 times 3? Won't that be 15 plus 7, which is 22? So don't we have a coordinate 122? That coordinate of 122 is your x1, y1. I just found my first coordinate of g of x at 1. So let's now do g of 4. Let's find the other coordinate, the other side. So 7 plus 5, square root of 12 minus 3 times 4. What does that give me? Well, that would give me 7 plus 5 times the square root of, what's 12 minus 12? It's 0. Oh. Okay, that would give me 7 plus nothing, which is 7. So that coordinate would be 4, 7. So wouldn't that be x2, y2? So now that we have our two coordinates, can we plug them in this formula and find the slope, which is the average rate of change? So let's do that. We have m, which is average rate of change, is equal to y2 minus y1. So 7 minus 22. And then aren't we also going to do x2 minus x1, which would be 4 minus 1. And when we simplify that, it looks like we have a negative 15 over 3, which is reduced negative 5. So my average rate of change on this interval would be negative 5. If you think about it, remember my graph looks like this? Isn't it always a decreasing slope? So shouldn't it be negative? So the slope along this picture I have here is a negative 5 from 1 to 4.